Hello class, in this video I'm going to be showing you how to solve an application problem that involves maximizing a quantity. Let's begin. So here are the 7 steps that you're going to see in this video. And if you take a look at the last step, you'll notice it says use www.phpsimplex.com to solve the standard maximization problem. So after I have completed all 6 of the previous steps, I'm going to use this website to solve the problem. Let's begin. So go ahead right now, pause this video and read this application problem. Welcome back. So the first thing we're going to want to do is define all the variables. So I'm going to look at the last sentence, and it states how many goats and how many pigs should she raise. So I'm going to go ahead and I'm going to let x1 equal the number of goats raised. And then I'm going to let x2 equal the number of pigs raised. Now we have to set up the objective function. So the second part of the last sentence states that she wants to maximize the total profit. So I'm going to find the sentence that describes the profit. So it looks like it's the second to last sentence. It states each goat produces $12 in profit and each pig produces $40 in profit. So here is the objective function. And that's where Z is the total profit. And now since we're going to be inserting this objective function into a Tableau matrix, I'm going to rewrite the objective function as such. Okay, now on to the constraints. She wants to raise no more than 16 animals. So that can be written as the following. No more than means she wants to raise 16 animals or less. Okay. She's also decided to raise no more than 10 goats. So goats is represented with an x1, so that's x is less than or equal to 10. And finally, it looks like she has a cost for raising goats and pigs. Looks like she spends $25 to raise a goat, $75 to raise a pig, and she has $900 available for the project. Okay, so now I'm going to go ahead and rewrite each of these constraints as linear equalities. Starting with the first one, I'm going to insert the slack variable S1, that's the first slack variable, and we're going to set the constraint equal to 16 now. Here is the second slack variable. And we are going to have our third slack variable inserted into the third constraint. Okay, now let's create the initial simplex Tableau matrix. There are 2 variables and 3 slack variables, and one variable z, which represents the total profit. So I'm going to go ahead and fill out the first row now. There's the first constraint. Here's the second constraint. Here's the third constraint. And finally, the objective function goes in the bottom row. All right, so before we can use technology to solve this system, you're going to be required to find the pivot. And if we take a look at the columns, it looks like -40 is the most negative indicator. So that means the pivot is going to be in the second column. Next, we're going to divide each of the entries in the last column by their corresponding entries in the second column. So here we have x2, I actually want to write it in black. So x sub 2 is equal to 16 divided by 1, which is 16. Unfortunately, you can't take 10 and divide it by 0, so we're going to skip that one. So we're going to do 900 divided by 75. So since 12 is less than 16, the pivot is in row 3, column 2. And the number that is in row 3, column 2, is 75. So the pivot is 75. And now that we have the pivot, we can go ahead and use Phpsimplex.com to solve this standard maximization problem. So here we go. So here is Phpsimplex.com, and the first thing you might notice is that it's all in Spanish. If you would like to change the language, go over here to Idioma and hit English. And now we're in English. Next, you're going to hit the blue link, Phpsimplex, like that. And you're going to be asked a few things. You're going to be asked, how many decision variables are in the problem? Well, the number of decision variables in this problem are 2. And how many constraints are in this problem? 3. Then you're going to hit continue. Now it's important to make sure that this little link up here, or this little tab, is at maximize for this problem. So we're going to maximize the function. Let me just get the objective function back up there. 12x1 plus 40x2. And now you're going to write down the coefficients of each of the constraints and make sure that this tab is on less than or equal to. So the first one was 1x1 plus 1x2 is less than or equal to 16. Then we had 1x1 plus 0x2 is less than or equal to 10. And then 25x1 plus 75x2 is less than or equal to 900. Hit continue. And notice that this website will insert the slack variables for you, but they'll still continue to write them as x's. So you'll see x3, x4, x5, Those are the Slack variables, and we don't write our Slack variables using X's, but you can if you like. And then what you're going to do is you're going to hit direct solution. And notice the optimal solution value is Z is equal to 480 when 0 goats are raised and 12 pigs are raised. So we're going to come over here, and we're going to write the total profit is maximized at $480 when 0 goats and 12 pigs are raised. And you are done. We finally answered the question.